All right. I was discussing about the output of the analysis. I was saying that you need to note down, first of all, the mean values of both groups, like in terms of standard groups, in terms of new promotion groups. Then you need to see the second table, and you need to check the sig value under the Levin's test for equality of variance. If this sig value under Levin test for equality of variance is greater than 0.05, we may consider that equality of variance assumption is fulfilled. It means we are dealing with the first category of the data. Then, when you go to the middle part of this table, you see here a t-value, a degree of freedom, and sig2 value. If t value is greater than 1.96 and sig2 tail value is less than 0.05, it means there is a significance difference between both groups. The mean value of the both group is significantly different. So the mean difference is also placed over here. You can take it. And the third table will show you the effect size of your analysis. You need to concentrate on Cohen's d, that is the point estimate, and you need to half down the value. I will share the table related to the guidelines of effect size. All right. So I have also provided you an example dataset file of dataset example 2 dataset file. You need to open it, and you need to basically check it. I will elaborate what the example 2 is related with, because in order to know the procedure, you need to understand how this procedure is applying. So you need to apply the same procedure on example 2. So what is the data set of example 2? We have 12 uh, uh, just a minute. We have 12 spider fobs. Fobs means those persons who have some phobia, regarding some persons having the spider phobia. So we have 12 spider fobs who were exposed to a picture of a spider, and 12 different spider fobs who were exposed to a real life tarantula. The group are coded using the variable groups. It means that 12 peoples are exposed to a spider picture, and 12 peoples are exposed to a real life spider, not a Spider-Man, but a spider. Their anxiety was measured in each condition. Anxiety is a continuous variable over here, while the two categories of the people, the one who were exposed to a spider picture, and the one who were exposed to real life spider, these are the two categories, while you have the anxiety level as your continuous variable. So what you need to check, is there a significant difference between the group exposed to spider picture and group exposed real spider? So you need to check the analysis with example number 2 dataset. I have shared with you in the chat bar as well as in your WhatsApp group. So you will need to check it. I will give you 10 minutes, so that if you were okay with the results, then we will proceed further. So we might have a 10 minutes over here in order to analyze the example 2. In between, if anyone having any questions until this level, he or she may ask. The remaining participants are requested or directed to apply the process that you have learned using example 1 on example 2. Yes, people are here. There are 13 people who have joined. So if anyone having any question, he or she may ask, or you may apply the drill 2 to understand the whole procedure on example 2 dataset. I will let you know that you have a dataset with example 2 name in the same folder, normal with equal variance. And you may also check the same procedure on example 3 also. So try to complete the procedure as early as possible so we may proceed further. In the meanwhile, I would stop the recording and we will start the recording from the point where we start the next part, and I will proceed further again. All right, we have completed our case one. As I have already let you know that I will consider the normal data with equal variance where independent sample t-test will be applied. And the second case is normal data with not equal variance. Here again, the independent sample t-test will be applied, but the equal variance assumption will not be fulfilled. So in your data set, what you need to open your normal with unequal variance folder. You need to open normal with unequal variance folder, and here you find two data sets, example number 4 and example number 5. Actually, first three examples are related with our first category, which is normal with equal variance. So as we are doing the next category, what is actually done over here? All right. So we proceed further with the case two. Our case one is completed. We will proceed further with case two, where the data is not normal, but where the data is normal, but our equality of variance is violated. So here comes the second case. First, we need the detail of this case. Normal data with unequal variance. When your data fulfill the normality assumption for a continuous variable. Remember one thing, whenever you need to check the normality, always check the normality of your interval or scale variable. Scale variable or interval variable is basically your continuous variable. So always check normality assumption for a continuous variable, which is comparable in two independent groups. The test appropriate for such data would be independent sample t-test. However, equality of variance is violated in this case. So we need to check example number 4, because independent sample t-test is the procedure which is applied in case 1 and case 2. Only your variance assumption would be violated. So in our sample data set, student reported their typical score of math and English and their gender, male and female. So score, the subject score are basically the continuous data, and you need to compare your continuous data in terms of male and female. Suppose we want to know if the average score of math and English is different for male and female. So what we would like, we need to compare the average score of math and English in terms of male and female, whether it is same or different. So first we need to set up our hypothesis. Our null hypothesis is there is no statistically significant difference in math and English score between male and female. An alternative hypothesis is there is a statistically significant difference in math and English score between male and female. So this is basically the construction of statistical hypothesis. Like if we are considering that there is no statistical difference between first group and second group, and if we consider that there is a difference, there is a significant difference between first and second group, we may state the hypothesis like H1. So what is the SPSS procedure? First, we need to check the normality. Then we need to check if data is normal. Then we need to use independent sample t-test. And then we need to check whether equality of variance assumption is fulfilled or not. So this is the procedure. First, we need to check the normality using the same procedure. Go to analyze button, go to non-parametric test, go to legacy dialog box, then go to one sample KS. Then you need to put your continuous variable, because here we are using two continuous variable, that is math and English. So you can put both of these two continuous variable in the test variable box, and you need to click OK, and then you can find out that both of. All right. There was a short interruption in internet connection. That's why I was disconnected, but I will start over again. I was letting you know that uh, in our case, what we need to do is we need to check the normality first. So we need to put our two continuous variable in test variable list, and then after clicking OK, you will see a result like this, and you will find out that asymptotic sig value of English and math both is greater than 0.05. It means that our data is normal. So our first condition was met. So how do we interpret this? Since the level of significance or asymptotic sig value two tail is equal to 0.2004 for both subjects, math and English, which is greater than 0.05. Therefore, the normality assumption is fulfilled. So what is our decision about appropriate test? As the data is normal, therefore independent sample t-test will be used for testing the hypothesis. However, this is the part where your learning will be take place. However, we will additionally need to check. However, we additionally need to check for equality of variance using Levine test of equal variance. So in this case, we need to check again the independent sample procedure, like using analyze, compare, means, independent sample t-test, and you will find out uh, in the table the mean value of male and female in English subject, the mean value of male female in math subject, and most interestingly, what you will find out Levine test for equality of variance. Here you can see the sig value under Levine test for equality of variance is less than 0.05. If you remember, I have told you that the Levine test value should be greater than 0.05 in order to fulfill the assumption of equality of variance. But if the sig value under Levine test for equality of variance is less than 0.05, it means your assumption for equality of variance is violated. In that case, you need to select the t value and the sig value of the second row, not the first row, because the second row is basically assuming the equality of variance not assumed. I would like to repeat here, whenever your assumption for equality of variance is violated, you need to select the t value, sig value, and all other values of the second row, because the second row assumes that equality of variance is not assumed, because here the assumption is violated. In the second case, in mathematics case, again the assumption is violated. So we will take the values, the p values, the sig value of the second rows, and you can also see the point estimate. So how can we interpret these values? The first thing, you need to see the mean values of both male and female in both subjects. Like if I need to interpret the mean value of English subject, I can say that there were 188 female having an average score of 82.7265 in English subject, and there were 213 male, they have an average score of 82.75 in the English subject. While in case of math, there are 198 females having an average score of 66.55 in mathematics, while there were 215 male with an average score of 64.33 in mathematics. And these differences are significant. These differences are significant. No, sorry. These differences are significant only in mathematics, because you can see in case of English, the t value is less than 1.96, and the sig value is also greater than 0.05. So we can conclude that the significance difference between male and female in case of English subject is not confirmed, or we can say that there is no significance difference between male and female in case of English subject, because the t value is greater than 1.96, and the sig value is sorry, the t value is less than 1.96, and the t value is greater than 0.05 in case of English subject. So we can conclude that the difference between male and female for the subject of English is not significant. So here we fail to reject the H naught. But in case of mathematics subject, you can see that the t value in the second row is greater than 1.96, and the sig value, two tail sig value in case of math subject is less than 0.05. So we can say that in case of mathematics, there is a significance difference between the average mean score of male and female. So in case of mathematics, our null hypothesis is rejected, but in case of English, we fail to reject the null hypothesis. So this is the way how we can interpret our data in the same way that we have done in the previous. Here you can see the point estimate of effect size that indicates a very small effect. So these are indicating very small effects, because these are less than 0.20, and it is very small effect. In case of mathematics, they are showing a medium effect like 0.268, but in case of English, it is showing almost no effect. So this is the way how we can interpret, like in the previous example we have interpreted. So you can interpret this table also by in your own words. So this is the APS style of interpretation. The result indicate that there is insignificance difference with the value of this and this in the mean score of English between male and female. The finding also indicate that male score more on average for English subject as compared to female. Uh, I have, due to shortage of time, I didn't put the mean values over here, but you can put it. The magnitude of difference in the mean uh, is this and this. Therefore, we fail to reject H naught. In case of English, we fail to reject H naught. But in case of mathematics, the result indicates that there is a significance difference in the mean score of mathematics between male and female. The finding also indicate that female score more on average for mathematics subject as compared to male. The magnitude of the differences in the mean score is this and this. Therefore, we accept H1. So this is the way how you can interpret. I have skipped values due to the shortage of time, but you can place your values. You can take the screenshot, or you can see the recording after I upload on my channel. You can see this slide, and you just simply need to place your values to interpret your results. So there is example number 5 for your drill. You are provided with the height data of male and female. uh, can you conclude that there is a significance difference in height for male and female? So you need to apply the whole process that I have applied to you. You need to check the whole process with your example data 5. So if you see your folder, I have run the procedure with example 4 and I have given you example number 5 in basically normal with unequal variance table folder. So you need to apply the whole procedure with example 5, and I stop the recording for a while so that you may confirm how this procedure is clear over here. So I wait for 5 minutes uh, so that you may apply the procedure. All right. After example number 5, we may proceed for case number 3. I have told you that there are 3 cases in this scenario. In two group comparison, there are 3 scenarios. At the start, I let you know about it. If you can see again, yes, this is the slide. I told you that there may be a normal data with equal variance. The second case was there may be a normal data with unequal variance. It means in the first two cases, the test sample or the test statistic will be same, but the assumption may or may not be violated of equal variance. But in the third case, the data may be normal. In whenever the data is not normal, we don't need to check any equality of variance. In that case, we need to apply Mann-Whitney test. So I have also shown it in this diagram or in this picture that first you need to check whether the data is normal or not using this procedure. If your asymptotic sig value is showing that it is normal, go for parametric procedure under equality of variance or inequality of variance. But if your data is not normal, which is our case number 3, we may proceed for non-parametric test, that is Mann Whitney U test. So we are going towards this procedure, that how we can apply the non-normal data procedure with two groups mean comparison. So here it comes. This is the case 2, example 5, and this is the case 3. So start over from here. So case number 3 is about two group comparison when data is not normal, when your data does not fulfill the normality assumptions. It means when your data is not normal for a continuous variable. Always remember, whenever you need to check the normality of the data, always check for interval or scale variable, not with the categorical variable. Whenever you need to check the normality, always check for continuous variable or scale variable or interval variable, not with categorical variable, which is comparable in two independent groups. The test appropriate for such data would be Mann-Whitney U test. You don't need to check the equality of variance assumptions. That is the important thing. Whenever your data becomes not normal, you don't need to check the equality of variance. The DV may be continuous or ordinal. Ordinal. So what is Mann-Whitney U test? The Mann-Whitney U test, also known as Wilcoxon ranked sum test, is a non-parametric statistical test used to assess whether there is a difference between two independent groups in terms of their distribution. It is commonly employed when the assumption of a parametric test such as the t-test are not met, especially when dealing with the ordinal or not normally distributed data. Here, median is compared as average instead of mean. The important thing is whenever you need to compare the mean, you are dealing with the normal data, and whenever you are dealing with the median instead of mean, you are dealing with the not normal data. So example number 6 that I will apply over here. Data on a birth weight of infants born to mothers with different level of parental care. Two independent samples data for univariate analysis. Can we conclude that there is a significant difference between the median weight of infants who provided parental care at the first trimester and the third trimester. This data is basically related with the mothers who are going to give birth to their child. If they have provided cares in the first 3 months during their pregnancy, so what will be the effect of that care on the weight of their child? And if they have provided care in the third trimester, it means the last 3 months of their pregnancy, what will be the effect on their child weight? So we need to consider two categories of basically the parents care on the weight of their child. That how is there any difference between the weights of infants if they were provided care using the first trimester care or by third trimester care? So how we can do it? First, we need to establish the hypothesis. Our null hypothesis would be there is no statistically significant difference in the median infant weights for the parental care provided between trimester 1 and trimester 2. Alternative hypothesis would be there is statistically significant difference in median infant weight for parental care provided between trimester 1 and trimester 2. And here comes the statistical basically your hypothesis. If both are equal, you may state it as a null hypothesis, and if they are not equal, you may state it as a alternative hypothesis. So how the procedure can be applied? uh, First of all, we need to check the normality of data using the same procedure that we are doing earlier. Then we need to check how the test will be applied. If the data is normal, you need to apply the independent sample t-test, and if the data is not normal, you need to apply the Mann-Whitney u-test. And here comes the procedure. uh, you need to go to analyze non-parametric test legacy dialogues one sample ks, and then you put your continuous variable or your scale variable in your test variable box and click OK. And if you find the asymptotic sig value which is less than 0.05, it means your data is not normal. So if your asymptotic sig value of one sample ks test is less than 0.05, it means your data is not normal. So what we need to do, we need to interpret it since the level of significance, which is asymptotic sig2 tail, is equal to 1 is equal to 0.001, which is less than 0.05. Therefore the normality assumption is not fulfilled, and what we decide about the test, as the data is not normal, therefore Mann-Whitney u test will be used for testing the hypothesis. Here we don't need to analyze the equality of variance when the data is not normal. In case of Mann-Whitney u test, you don't need to analyze the equality of variance. So how we can analyze the data? You go to analyze non-parametric test legacy dialog box, and here we have an option of two independent samples. You need to check it. You need to put your continuous variable in test variable list, and you need to put your categories variable into grouping variable, and you need to define it, and you need to check the Mann-Whitney u test table. And you will find a table like this, like the weight of the children who were given care in the first trimester were on average 25.50, and the care which was given to the children with third trimester is more, is basically the 75.50. So it is, this difference is significant because the value of test statistic is less than 0.05. So